Before the 19th century, science was all about observing nature, and light was thought to be made up of particles. But then, Thomas Young came with his double slit experiment, proving that light is a wave as well. The confusion began with the strange wave-particle duality of light, and then further spread to everything that's made up of matter. Yes, even the electrons that make us and everything at the most basic level behave like waves. When electrons were fired one at a time through a double slit, a pattern was obtained on the screen. But instead of getting two straight bands as expected, we got this. This pattern is produced when a wave crosses the two slits and creates two new waves, which interfere with each other. When two peaks or two valleys meet, the length of the wave increases, forming the bright spots. But when a peak meets a valley, no wave is formed, hence the dark spots. But this happens when a wave crosses two slits at once, whereas an electron can go through only one, right? Let's see. Anyways, to know which electron passed which slit, we introduce light. So that when an electron passes a slit, we get a flash. This is the observer effect, which means observer affects reality. See, unlike our everyday life, we cannot tell the position of an electron. In quantum mechanics, we talk only about possibilities of finding an electron at some place. So before measuring, it could have passed one slit, both slits, or neither. However, when we try to see it, it was found at only one place. And once it is there, the probability of finding the electron at that point becomes 100%, and all other probabilities become zero. This is called the collapse of the wave function, and the electron now behaves like particles. But who tells them if they're being observed or not? Well, it's us. Remember, we used light to determine which electron passed which slit? Perhaps the light was interacting with the electrons and changing the result. For example, you have a piece of wood. To know its burning ability, we need to put it in fire. And to know its floating ability, we need to put it in water. Here, we are interacting with the wood to observe its behavior. The wood may or may not possess one or both of these properties, but it is us who determine which behavior will be seen. Similarly, the electrons reacted according to the conditions they were put in. That means the way we decide to look at things affects the results that we get. So be careful about your decision.